So now your stock also will go. Okay, your now stock is 0. Okay, so we don't have any requirements or receipt elements, and even the stock is also 0. Okay, now we'll start with minimum lot size and maximum lot size. Okay, so we'll discuss on this minimum lot size. So the minimum lot size means your production or your procurement cannot be lesser than that particular quantity. Okay, you should be always producing or procuring more than particular one quantity. Okay, so that is what the minimum lot size. I'll show you the effect of this. If you go to the material master again, /mm02 /mm02, I'll go to the material master. Okay, here again I'll change it to EX, lot to lot quantity EX, and here I will be maintaining the minimum lot size as let's say 200. Let's say 200. Okay, I'm saving this. That means here always you will be producing 200 or more than 200. You cannot produce less than 200. Okay, you cannot produce less than 200. Okay, now let's see the effect of this. I'll enter one planned independent requirement. Only one I will be entering now. Okay, I'll be entering only one. I'll be entering only 100. Okay, I'll enter only 100. Save it. Enter. Okay, now you see the planned independent requirement. Okay, your requirement has come. Now when I execute MRP, /MD02, even though requirement is 100, you see what is the planned order quantity. Okay, the planned order quantity will be, the planned order quantity is 200. Why it is not 100? Because your minimum lot size itself is 200. That means you cannot produce less than 200. You cannot produce less than 200. Either you can produce 200 or more than 200. So that's why the planned order quantity is 200. Okay, again this is used actually. This is again used normally for raw materials. Well, your vendor says that if you give quantity for 50, 30, I cannot supply. That will not be commercially not viable for me. I will always supply 200 or more than 200 pieces or kg, whatever it is. Okay, so those kind of scenarios, what you will do is you will be maintaining the lot size as minimum lot size as 200. Of course, here the requirement is 100. That's why it has got 200. Suppose if the requirement is 500 here, then the planned order will come for 500 because it is more than 200. So more than 200 you can produce or procure. Suppose I'll change the independent requirement. Now I'll change this to 500. Okay, I'm changing this to 500. Now when I execute MRP again, you see what will happen. Enter, enter. Okay, now go to the stock requirement list. Now your planned order quantity is 500. That is because it is more than, it is more than 200, right? So that's why it's got generated for 500. Okay, so whenever it is less than 200, it will generate for 200. So minimum lot size is 200. Less than 200 you cannot produce or you cannot procure. So that is what the use of minimum lot size. Okay, wherever you are not comfortable or not able to understand, here you can ask minimum lot size and maximum lot size. Okay, now the next one is the maximum lot size. So the maximum lot size means here it's a reverse of minimum lot size. So what happens is maximum lot size up to certain extent only you will be able to produce or you will be able to procure. More than that you cannot do. Okay, so that is what the maximum lot size. Okay, so we'll change it to maximum lot size and we'll see the effects. Again I'm going to the material master, enter, enter. Now I will be using maximum lot size. Okay, so my maximum lot size is, let's say I'll put it as 250. I'll put it as 250. Okay, that means here I can produce up to maximum 250 or less than 250. More than 250 I cannot produce. Okay, more than 250 I cannot produce. So now I'm saving this. Okay, so now I'll change my planned independent requirements again. Okay, here I will be making it, let's say I'll be making it 300. I'll be making it 300. Okay, 300. Okay, so now let's run the MRP. You see what will happen. Okay, I executed MRP. Now you see the result. So you will be getting a 2 planned orders. See, requirement is 300, but as per our settings, we will be producing up to maximum 250 only. So that's why you got a planned order for 250, and the shortage other remaining quantity is 50. So you got one more planned order for 50, because up to 250 you can produce any quantity. Okay, so that's why you got 250 and 500. Okay, if your requirement could have been 200, if your requirement could have 200, you could have got a planned order for 200 directly, because up to 250 you can produce any quantity. So the maximum cutoff is 250. This is also here again used during the procurement process. Your vendor says that my truck capacity is 250 only. I cannot supply more than 250 at one shot to you. So those kind of scenarios you will be using this maximum lot size. Okay, so this minimum lot size and maximum lot size is normally used when you have certain constraints in your production or in your procurement process. So that time you will be using this minimum lot size and maximum lot size. Of course, I have shown you two things separately. Here I have shown you two things separately. Of course, you can have both ends together also. You can have like this: minimum lot size 100, maximum lot size 250. Then all your planned orders will be in between these quantities. Both, you can use both together also. Okay, so that is what the importance of minimum lot size and maximum lot size. Okay, so that's what. Now we will be discussing on the scraps. Okay, now we'll be discussing on the scraps. So scraps, we have three types of scraps in the system. One is the component scrap, one is a component scrap, next one is the assembly scrap, and the third one is the operation scrap. Okay, we have three scraps in the system. Okay, these scraps also will be affecting MRP run. So we need to understand what are the scraps, where they are maintained. Okay, all those things will be understanding. Okay, so let's start with one by one. Okay, so first one will be the component scrap. Okay, component scrap. Or let's first start with assembly scrap. Okay, you will not be getting assembly scrap. Okay, what is this assembly scrap? Okay, so assembly scrap means when you are producing a product, let's say you have some loss all the time. Okay, let's say you are producing 100 kg. You're producing 100 kg. So during the production process, what happens is there is a chance of getting some loss, getting some scrap. So ultimately, let's say you are getting only 95 kg. Let's say. So what is your planned quantity? 100 kg, and your final output is like 95 kg. So you are getting less output, less quantity. So to compensate for this, what you do is you increase your planned quantity by 105 kg. You increase your planned quantity by 105 kg so that your final output you will be getting as a 100 kg. Okay, so this is what the assembly scrap. Okay, assembly scrap increases the quantity of your assembly, your finished product or your semi-finished product. At the same time, it increases the quantity of all components. By that particular percentage. Okay, now the question is where it is maintained, where the assembly scrap is maintained. Assembly scrap is maintained in the material master for our assembly. Okay, so in our case, if you go here, now I'll remove all this minimum lot size, maximum lot size, enter once. I'm saving this. Again, I'm going to the material master. Okay, here you are able to see one assembly scrap. Assembly scrap is maintained. It is always maintained in percentage. So here I will maintain 5%. Okay, I am maintaining. Assembly scrap is always maintained for the header material. Your header material. Okay, that's what you need to understand. So it is 5% I maintained. Now I am saving this. Okay, now I'll enter requirements. Again. Okay, I'll enter requirements again. Okay, I entered 1, 2, 3, 4, 5. I entered for next 6 months. I'm saving this. Okay, refresh. You got the planned independent requirements. Now I'm executing MRP run. Okay, I executed the MRP run. So when I execute MRP run, if I refresh, so you got planned orders, okay. Now when I'm trying to convert the planned order to production order, so you see what will happen. Actually, what is our planned order quantity? It's 100, but the moment I'm trying to convert to production order, double click on the planned order. When you try to convert the planned order to production order, see what is the quantity now. The quantity got changed to 105. So that 5% of 100 is 5. So it added to the 100 quantity. Now your total quantity has become 105. Okay, and when the assembly quantity gets increased, when the header materials quantity get increased, correspondingly the component quantities also will get increased. See, the component quantity is also increased by 5%. 105, 105, 105. That's what you need to understand. Assembly scrap not only increases the header material quantity, it also increases the component quantities also accordingly. So the requirement for the down level components also will get increased accordingly. Okay, so that is what you need to understand. Assembly scrap is normally increases not only header material quantity, it also increases the required quantity of all components. Okay, so that is what the assembly scrap. Okay, these scraps which we are discussing now, this is normally used in production. They are normally used in production. Okay, so your end users or your client says that when we are producing the quantities, we are always getting some lesser quantity as output. So we need to compensate for that. What we have to do? So then you have to propose this assembly scrap to them. Okay, so that's what the assembly scrap. Now the next one will be the component scrap. Component scrap. Okay, so this component scrap is applicable only for a particular component. It increases the required quantity of a particular component. Okay, it is not applicable for all. Okay, now where this component scrap is maintained, let's go to our situation. I am not going back, I'm not saving the data. Okay, let us see the BOM situation of this particular material 2094 /NCS03. Okay, so in the 2094 material, okay, we have Coke solution, empty bottle, bottle caps. So these are the BOM of this particular bottle. Okay, now let's say when producing, we are always getting some loss of Coke solution. Okay, to compensate that one, the organization, the client decided to increase this Coke solution quantity. Okay, so what you need to do is you take this Coke solution, then go to its material master, MM02, go to its material master. Now you need to go to MRP4 view. Component scrap will be maintained only in the MRP4 view in material master. Okay, so here you are able to see component scrap percentage. Here you maintain that 5%. Okay, enter. Now you save it. And for the header material, now I will remove the assembly scrap. Already for header material, we already have assembly scrap, right? So that I will remove. And then we'll see the effects. Header material, I am removing the assembly scrap. Okay, now I'm saving this. Okay, now I'll run MRP again for the same situation. I'll run the MRP again for the same situation. /NMD02. Okay, 2094 is my header material. I am running MRP. Okay, I executed MRP. Now let's go to the stock requirement situation. Okay, you got planned orders. Now when I'm trying to convert the planned order to production order, okay, see, assembly quantity, your header material quantity remains the same. Why? Because now I remove the assembly scrap. But if you go to the components, what happened? The quantities of 2108, 2109 is according to the requirement, but the quantity of Coke solution got increased by 5%. Okay, as we maintained component scrap for this particular component. See, in the industries, what happens is when you are producing the product, some components will be consumed more all the time. Let's say you are working in ice cream manufacturing industry. For a manufacturing ice cream, what you will do, you use some powders and liquids, so that liquids all the time may get stick to the machinery. Okay, so there is a chance of liquids getting stick to the machinery. So in those kind of situations, what will happen? You have to take more liquid. So those kind of scenarios, for those liquid materials, you will be increasing the quantity. Okay, so that is what the component scrap. Now the component scrap, you can maintain it two places. One is in the material master, another one is in the BOM. So if you maintain this in the material master, what happens is, this particular component not only used in this one, this scope solution, not only used in this product, it might be used in lot of products. It might be a component to lot of finished products. So those kind of scenarios, if you maintain in the material master, it will be applicable where it is used in all the components, all the products. And if you want to maintain this component scrap only to specific to particular product, then you will be maintaining it in the BOM item details. So if you go to the BOM item details, I'll go to the BOM item details /NCS02 2094. Take the Coke solution, you go to item details. Try to recollect our old BOM classes. Okay, we selected the item and we went into item details. So if you go to the item, here you are able to see component scrap is maintained. So here you maintain. If you maintain here, this scrap of this particular material, this component, will be only applicable to this product, not for other products where this component is used. So that is the difference. Effect is same, only thing is you want to make it product specific or for all products where this particular component is used. That is what determined. Okay, so you can assembly scrap, you can maintain in the material master only for assembly, only material master. But component scrap you can maintain in the metal master or in the BOM item details. If you maintain in the material master, it will be applicable where this particular component is used in all the products. If you maintain it in the BOM, it will be applicable only to that particular product where this component is used. Okay, so that is what the component scrap. Okay, so now the last one will be the operation scrap. So what is this operation scrap? What happens is, during your production activity, operation scrap. What happens is, during your production activity, let's say your production is having 3 steps. Let's say operation 10. Okay, so operation 10, let's say operation 20, and then operation 30. Okay, you have 3 operations in your production process. Okay, let's say now you are producing your planned quantity is 100 kg. Your planned quantity is 100 kg. Let's say. Okay, now after producing the operation 10, when you started with 100 kg for operation 10, but after producing the operation 10, there is a loss of, let's say 5 kg. Let's understand there is a loss. Of 5 kg. Okay, now in the operation 20, normally ideal scenario, what should be your operation quantity? Your operation quantity should be 95 kg, not 100, because already you lost 5 kg. Okay, so your operation 20 and your operation 30 quantity will be 95 kg normally. Okay, 95 kg. Even operation 20, after operation 20, let's say you have another 2 kg loss. Then your operation 30 quantity will be, normally it will be 93 kg. So this is called operation scrap. These are called operation scrap. So according to this operation quantities, you will be changing your operation duration, all those things you will be adjusting. So for those kind of scenarios, your operation scrap is used. Now we will see in the system how this is used. Okay, let me remove all the other scraps now. Let me close this. Let me go to material masters. First I will remove all the scraps. /M02. What is that component? The component is 2107. 2107. I'll remove all the scraps. Okay, now the question is where this operation scrap is maintained. Operation scrap is maintained in the routing. In the routing operation details. It is maintained in the routing in operation details. The operation details. Okay, so I'll maintain that and then we'll see what will happen. Okay, so I'll go to the routing of this material, CA02. We already discussed what is routing, how to create routing, all those things in our master data class. Okay, try to recollect our routing classes, old routing master data classes. So I'm going to the routing. Okay, so in the routing we have three operations. One is empty bottle washing and drying, then filling, and then packing. Okay, so here let's say I'll maintain some scrap over here. Go to details, select the operation, go to detail operations. Okay, scroll down. Okay, here you are able to see you are maintained. There is some scrap in percentage. Here I maintain it as 5%. Always remember the scraps are maintained in percentage. They are maintained in percentage. So the 5% I maintained over here. Now go back and you save this. Okay, so I saved the routing. Now for the same situation, I'll be running MRP again. I'll run MRP again. Okay, so /n md02. Okay, I'm running MRP again. Now you see the effect of that particular operation scrap. So you got your planned orders. Now when I'm trying to convert this planned order to production order. Okay, so as I removed all the assembly scrap, now there is no change in the quantities. But if you go to operations, we have operation 10, 20, and 30. So now if you scroll to the right, see the first operation quantity is 100 pieces. Okay, now the second and third quantity operations got reduced by 5%. So operation scrap reduces the quantity of subsequent operations, not that particular operation. We maintained scrap for this operation, but it reduces the quantities of subsequent operations. That's what it do. So according to this quantity, you will be changing your machinery timings, all your activity timings and all will get adjusted. That's what the use of this operation scrap. Okay, so that is the use of this operation scrap. So these are the three scraps you will be using in the system. So if you go to an interview, normally they will be asking these questions. What are the scraps? Where you will be maintaining? If you maintain at what place, what effect it will take place? All those things they will be asking. So these scraps also will be having an effect on MRP. When you run MRP, system will consider the scraps which are maintained at various places in the masters. That's what the importance of the scraps. Okay, so this is all for today.